Solar energy is a tremendous source of energy that has not been exploited for many years in the Arab Gulf countries in general and in the Kingdom of Saudi Arabia in particular. The innovativeness and the vision of our leaders, represented by the leadership of the young inspiring Prince Mohammed bin Salman in the vision of the Kingdom 2030, has opened the door wide for the scientific and material investment of this energy, which will put the Kingdom at the forefront of countries benefiting from solar energy due to its distinguished position on the global solar belt. To keep up with the Kingdom's Vision 2030, and after announcing the largest solar-powered city in NEOM, a scientific team from the King Abdulaziz University led by Professor Nidal Abu Hamda, Engineer Azam Farhan, Engineer Ahmed Ashur, sponsored by King Abdullah City for Atomic and Renewable Energy, Center of Research Excellence in Renewable Energy and Power Systems, designed, installed, and commissioned the first small model of solar energy tower technology in the Kingdom of Saudi Arabia. What is solar tower technology and how does it convert solar energy into electricity? This is what we will answer in this brief. Concentrated solar power uses mirrors called heliostats to reflect and concentrate the sunlight onto a heat exchanger called a receiver that sits on top of a 7 meters tower. Within the receiver, fluid flows through the pipes that forms the external walls of the receiver and absorbs the heat from the concentrated sunlight. In this technology, the fluid utilized is molten salt, which is heated from 280 to over 550 Celsius. Molten salt is a salt mixture of sodium and potassium nitrites. 60% is sodium nitrite, while the other 40% is potassium nitrite. Molten salt is an ideal heat capture medium because it maintains a wider operating temperature range in liquid state, allowing the system to operate at a low pressure for superior and safe energy capture and storage. In this technology, liquid molten salt acts as both the energy collection and the storage mechanism. After passing through the receiver, the molten salt then flows down the piping inside the tower and then to a thermal storage tank where the energy is stored as a high temperature molten salt until electricity is needed. When electricity is required, the high temperature molten salt flows into the steam generator as water is piped in from the water storage tank to generate the steam. The result is a high-quality superheated steam to drive a steam turbine to generate reliable non-intermittent electricity. Once the hot salt is used to create the steam, the cool molten salt is then piped back into the cold salt storage tank, where it will then flow back up the receiver to be reheated as the process continues. The steam generation process is identical to the process used in conventional gas, coal, or nuclear power plants, except that it is 100% renewable with zero harmful emissions or waste.